Hello, Exactrix owners. We're out in northern Alberta today, up around Grand Prairie, Alberta, banding in triammonium polyphosphate sulfate. We're also injecting a third product into the flow using a 2KR blender. We're going to go back into the flow lab in Spokane, and we're going to go over how these systems actually operate together in unison. So almost a symphony in the field when you see all this begin to happen as the operators maintain high availability running in very difficult, muddy, sticky soil conditions. Here we go into the flow lab. Thank you. It's the 4th of July, darn near. July 3, we're out here in the flow lab, and we're going to explain an advanced system that's going to Nebraska next week, and this system is a 2KC Series 3 Weighmaster, a 2km TAPPS Formulator, and a 2KR blender. And the system is actually controlled by an ag leader. So Troy is going to take over and lead us through the engines, and he's going to compartmentalize here. It might look a little confusing initially. Not to worry. We're going to concentrate on the 2KC Weighmaster initially and explain mass flow. We'll take a look at all the different features that are on here. I think the real purpose of this particular meeting is to get you familiar with the nomenclature and where it's at, where these parts and components are at, because there really truly is an Exactrix speak. There is a nomenclature, there is a glossary. And so you'll be finding that in your technical manual as you read through it. So Troy is on the Great Plains, constantly working all the way from Texas up into Alberta. And he's seen a lot of these machines run, and he's in here today to explain to us the nomenclature and how the systems operate. Okay.
Start out, we're going to discuss the 2KC system, which is the ammonia part of this deal. We have 3 systems set up here, but we'll start with the 2KC. If you'll notice, we have this large filter housing, part we call it the laminator. So when we have the phone calls and everything, and we talk about the laminator or the filter housing, this is the biggest part of it that we discuss on here. This is where your ammonia comes in from your tank and where it is primary filtered before it goes into our system. The next part that is as a very integral part of the deal is when it comes through here, it comes into the pump, and it's part of the laminator system too, and this is where your vaporizer lines come off of, etc., etc. This is the vaporizer. This is the cooling part. If you'll notice, we have an extremely small line. Our vaporizer, we don't have to have a whole lot of liquid reflow to get the vaporizing system to cool down going. As it comes through here, it comes into the pump, and the pump is what pushes it up through into the mass flow. The mass flow is an integral part of our ammonia systems because we weigh our product. It is exactly what it says, exactly what we're putting on, exactly what we're putting on is going through that mass flow. The other side of it too is it's a diagnostic tool. It has lights on the front of it that will tell you if you're getting vapor flow or liquid flow. If it's red, that's vapor flow. If it's green, that's liquid flow. If it's yellow, you're not getting a true liquid state, and that's when then we can go back and say we're getting a flow problem from a tank, we're getting a flow problem from a filter, or we're getting a pump problem. Then on top, and then after with all this going on, we also have our phase loop system, which is basically keeping the pump running a certain RPM that will keep the flow of ammonia smooth. This is a very good part, very important part of the system because you have to know where to set this. And when we discuss it on different technical issues, sometimes if we're trying to get massive flows out of our system, we have to close this down. When we're doing low rate stuff, we have to open it up so this pump has a baseline RPM. And you'll notice when we get further in, all of our pumps have somewhat of a baseline RPM to make the smoothing effect, to keep all flows exactly what we want them to be. It's all run with a hydraulic motor and a hydraulic control valve. This is when we talk about a hydraulic control valve. This is the body of it, but this is the cartridge. And this cartridge, you do not separate the cartridge from the the meter that goes down in here, because it all has to be one unit and it's all calibrated in our shop to be exactly what it is. After it comes through the mass flow meter, we come into what we call the modulation valve. The modulation valve is another way to hold pressure against the system to keep the liquid state. And when we go to massive flows, we have to run this out, or it's not doing as much. When we're going low flows, we have to keep that pressure against our system so it'll stay in the liquid flow state. Coming out of there, if you'll notice, there's this small line going over here. This is the part of the bleeding system at the beginning. So when you're trying to get the system cooled down and getting ready to start, you use your bleed system, and it will bleed liquid through to get your vaporizer cool to get the liquid state sooner. Okay, some of the safety features that we have on these and requirements is we have pressure gauges. We have pressure sensors. Any place that we need to monitor these pressures, these areas that could be trouble, or why we're having issues with a rate or getting a rate or too low of a rate, is we need to be able to look at these pressures. So any place that's extremely important to know as daily operation, we have going through our boxes with gauges, electronic gauges in the cap. Some of the other places we just have gauges because these are something you just need to be able to go look at if I ask, or someone asks you, hey, what's the pressure in your laminator? What's the pressure there? So that's the reason we have these gauges. We also have the safety features of drain down. We have the ability to drain down, you can shut off your tank and we can drain down the system and get rid of all the liquid ammonia in the system. We have the ability, if you have a tank valve that is stuck shut, we have the ability to shut the system down and get high pressure here and blow a tank valve open in a tank that's stuck shut. All those things, every piece of this machine has a purpose. None of it can be gone around. It all really needs to be there to have perfect, exactly what you want fertilizer applied at any given time. The next part we'll move to is we're going to move to the 2km system, which is the central part of the liquid system to do our TAPPS formulation. On it's a pump, it's a hydraulic control valve, it's a filtering system, and we have mass flow on this one. And mass flow has become an important part of the liquid, just so for exactly controlling your liquid, also for the side of, you can check up on your fertilizer dealer to make sure that you're getting the fertilizer that you're supposed to get, because it measures specific gravity of the fertilizer product. What we have here is we have a positive displacement pump. We have a primary filter that has the capability of being cleaned without taking it apart. We can use high pressure water out of your cruiser or your fertilizer or your liquid delivery water tank. We can push water through this and we can clean this filter. So it's another way to keep your product clean going into your TIOs and all that and your manifolds. But we come into our filter, we come out of our filter into the pump, and the pump comes up here. If you'll notice, we have a ball valve right here. It's our baseline. We were discussing the baseline on the 2KC to keep the pump running smooth. This does the same thing on the liquid pump. This liquid pump has the capability of a lot of gallons per minute. So by putting this baseline on, we're basically making this pump have a baseline RPM that makes it smooth, makes the flow smooth. We don't have the chug-chug effect of the fluids coming out. Above that, we have our pressure relief bypass. So when you shut the booms off at the end of the field or any other reason, it bypasses that, so you can do your pump stays running. So it has immediate effect on rate. You hit your master back on, you're already at rate. You don't have to worry about that rate having to climb up. There's no lag. It comes out of here when you're running. It goes into the mass flow meter. This mass flow meter does basically the same as the ammonia side. It's got the lights on the front that are for diagnostics, and it also records all your pounds, all your gallons that ever goes through there, so you can check every field. It is very, very accurate, plus or minus 1% compared to scale tickets on weighing in and out. It comes through there. We have shutoffs on it so you can isolate each part of the system. If you have a problem, you can isolate each part. If you have a leak or anything else, it comes through the mass flow and goes to our manifolds. Okay, we're going to move to this third product. This system has a third product, so we can add potassium, we can add zinc, we can add any of the other third products that we want to add to our main product, main liquid product. We can add with this third system. I want to introduce Robert here. He's actually does 99% of the technical stuff here in the lab. I just take care of it out in the field and kind of come up and bug him once in a while. But we'll start out with part of this. This system does not have a filter on the stand with it. We have to have a filter from its product tank before it comes to this system. This is the filter that we will provide with the system. It's big, has easy flow, but it does keeps the product clean. The products have to be clean. We do everything under such high pressure, under such scrutiny on going through TIOs. We have to have clean product. Anyway, it comes from the filter and goes into, and if you'll notice, we have a smaller pump than that one over there. But this pump is still a positive displacement pump. It's still is capable of a lot of different rates. We can go a super low rate, we can go to a higher rate, and we add this straight into the liquid flow of the main 2km. This is called a 2kR. And then we also have, if you will notice, we have two magnetic flow meters on this one. That way we have the ability of doing multiple rates. We can go to a smaller flow meter for our really light products that we're only putting on a half a pound or a half a gallon per acre, even down to ounces per acre, 3 and 4 and 8 ounces per acre. We can use, and then we have the higher rate one that we can go up to 5 or 6 gallons added to the products. But it's a very simple system. It's still the same thing. We have a hydraulic control valve, we have a hydraulic motor, and we have a bypass. When it comes from here, it gets injected into the 2km. The 2km has a check valve right here for this. So this product, you cannot push that product into here. That way you don't have any pre-blending. It goes into what we call our sparging reflow. Inside of here we have a tube that injects the fertilizer in the entire length of the filter, so it's a complete total blend when it comes out into the pump of the 2km. So we have an exacting product coming out. This is a fertilizer manufacturing machine going through the field at any given time. This system here is really integral part if you want to variable rate and you want to do multi-product and control all the products separately instead of having your fertilizer dealer or yourself doing the blends. This gets it down to the deal that you know you only need a half a gallon of zinc on X amount of acres. That's all. This pump here will do it variable rate into the main system. I wanted to go back and explain all of our different pressure gauge boards here. We have the capability of monitoring nearly all the pressures in the cab of where and RPMs of the motors of where we need to monitor them for diagnostic reasons, for normal operation reasons. We monitor our incoming ammonia pressure, we monitor our pump pressure through the phase lock, we monitor our outgoing pump pressure, and we also monitor line pressure of the ammonia, clear down on the lines themselves, so we know the pressures are equal side to side, etc., etc. On the liquid side, we monitor bypass pressure, we monitor incoming liquid pressure, we monitor outgoing liquid pressure, and we monitor manifold pressure. On the 2kR, we monitor outgoing pressure and we monitor the baseline pressure. All these pressures are so important to when we have any diagnostic reasons or just normal operations. As an operator, you will know that when the pressures are at this point and your temperature outside is this and et cetera, you know the system is running nominally. It's doing exactly what it's supposed to do.
At this point, we're running all three products simultaneously, and then the screen here it shows about 80 pounds total in. We're showing about 13 gallons of ammonium polyphosphate and thiazole, and about 3 gallons of KTS as an example. It's a third product injection into the mass flow system. And of course down here you'll see the pressures are displayed. In the upper left there is the ammonia pressures that we're dealing with. So that's the 2KC system here. This is the 2KM here. It's a little bit lower pressure, 43 pounds. So those pressure gauges are different locations in the system. And then these are back pressure systems and phase lock loop pressures that we're looking at here. This is the tachometer system. The upper one is the 2KC. The lower one is the 2KM. The 2KM has its bypass baseline opened up, so it's running about 70 RPM higher than what it would normally if it was closed. It's called the baseline bypass. It's this item right here that's vibrating a little bit, and you can see the pressure gauge on there. That's the pulsation of the diaphragm pump. This is a 4-cylinder pump in service here. And of course, you can see the mass meter here is reading out the pounds per minute that we're applying. We're applying about 67 pounds per minute at this point. And so this mass meter is very accurate. It'll also read the bulk density of the material, so we can check and make sure that we have 10.5 pound material. It's actually carried out 3 digits. So when we blend the polyphosphate and the thiazole, that begins to change the bulk density, and then we only meter by the pounds, not by the gallons. Very important piece of technology is the 2KM Weighmaster. Catches a lot of mistakes, just real simple, honest mistakes made at the fertilizer dealership. Over here, right adjoining it, is the 2KM, and it's metering at about 3 gallons per minute, and it's metering its flow into the 2KM. So it's actually making a blend right here at this point with a sparging reflow blender. And so we're blending, in this particular case, we'll call this potassium thiosulfate. It's being injected into the flow of the ammonium polyphosphate and the ammonium thiosulfate. We can use other materials too, and those materials are often related to micronutrients or new nitrogen stabilization products. 2KR is what we call this system, 2KR blender, and it has 2 flow meters. Right now we're using the smaller flow meter that'll go, actually we can go right down to about 1/4 gallon a minute, about 1/4 minute. And then of course this is the flow meter for much higher flow rates, and we simply connect up for the correct flow that we need to do. So 2KR blender is a critical tool that's utilized for scientific evaluation too. So many producers want to find out what is the right nutrient program in the field. And so they can write a program and they can adjust the 2KR blender up and down across the field, and then immediately get yield results very quickly. So they can do a lot of on-farm testing to get superior results. So that kind of explains the story. Up in the cab will be the tachometers and the pressure gauge panels, actually 3 panels. And we'll be using an ag leader controller in this particular case. And at this point it's metering 80 pounds of nitrogen as NH3, 13 gallons of ammonium polyphosphate and thiazole, and 3 gallons per acre of potassium thiosulfate. So we're running in a blending mode and actually injecting those materials together inside the opener in the ground, forming crystalline TAPPS, or TAPPS if we're using potassium thiosulfate. In conclusion of today's training seminar here, I'd like to point out we use 3 different types of controllers presently, and we use mass meters, and we also use accumulator manifolds and very small orifices to control the injection of the NH3. And these orifices are critical to get the uniformity across the machine width. The net effect of this technology makes the nutrients more crop available because of the uniformity and the high pressure of the injection. And typically the nitrogen will be applied at 166% more crop available, and the phosphate will be applied at about 200% more crop available over any other technique. So these are powerful tools that the producers pay for in one crop. The typical toolbar has a 1-year payback. So I hope you understand a little bit more about how the system works, and we'll look forward to a few more meetings in the future. Thank you.
Welcome, no-till farmers from around the world. This is Guy Swanson reporting in today with Alex Renner and Tim Gross, and we're at the Spokane Hutterian Brethren banding anhydrous ammonia and polyphosphate and thiazole making TAPPS. We're basically operating in a no-till scenario. That's the end of the agricultural world you see there. The Arctic Circle shows up in about 1,100 more miles. Yes, sir. This is a high production area, shallow soil conditions in this particular part, but able to produce good yields in the 60 bushel range. That's the Spokane River right along the center pivot production area where a lot of seed production is located. Here's the Burgo 3710, and we're demonstrating to you today the injection of anhydrous ammonia with the front gang. So keep your eyes on that front gang. We're using the 2KC Weighmaster Series 3 and injecting at pressures to 300 psi. Those injection pressures are combined with a flow of polyphosphate and thiazole. The mass flow system weighs the material and is highly accurate within about 20 pounds on 10,000 pounds applied. We also use the 2KM Weighmaster, which applies these liquids at very, very high levels of accuracy and double checks the bulk density as we apply it so we can catch mistakes at the fertilizer dealership. So bulk density readout allows us to check our blend. There you go, and notice the injection of the NH3 and the good sealing, and that's done with these unique injectors that we've developed in combination with Tim and Charles Gross, working very intently on making this Burgo opener seal perfectly. And they installed a larger blade. It's about 22 inches in diameter, and of course the injection is on 20-inch centers. And so there's a mid-row band, and there's an illustration of how it injects in 3-product delivery. The ammonia is held as a liquid all the way to the injection point, and that's what gives it the 1% CV of application. It forms the crystals of TAPPS, which, by the way, is one of the most crop-available nutrient packages available. Very interesting machine, and of course a good illustration of how uniformity works. Quite often producers think they can apply twice, and it actually gets worse with high CV applications. The conditions here were just absolutely ideal for banding and seeding on April 28th at the Spokane Hutterian Brethren, just north of Reardon, Washington, and just above the Spokane River Canyon and the Colville Indian Reservation. This has been one of the most outstanding machines in Class 3. Of course, you deer owners know you have Class 1 machines, the 1890 and 1895. These Burgo units are built much heavier, much more durable, able to handle a lot of extreme conditions, and actually built in Saskatchewan where it's really difficult to begin with. So you wouldn't be dragging one of these around in Iowa, but it fits in Texas and Kansas and Colorado. Ideal machine for raising no-till crops. Class 3 means that it's able to handle very steep slopes. Class 5 would be a yielder. Here we go, banding deep into the profile and looking for high yields in spring wheat. Well, it's been a great day out here with the brethren, and these are the pioneers of no-till in the Pacific Northwest. We congratulate them for an outstanding job with the Burgo 3710.